Hello guys, I am Satyam and you are here on our one and all channel Satyam Ideal Learning. And today we will be going to discuss about gas and liquid pressure. At the very first I want to tell you about what is pressure. See, pressure is thrust upon area. Now, what is thrust? We have studied what is force. Force is push or pull, okay, but in this pressure we are going to study on compressive force, okay. So this pressure comes in thrust upon area, okay, thrust upon area. And what is thrust? Thrust is compressive force, only pushing. We are not including pulling, okay, we are including only pushing in this pressure. So thrust is compressive force and area you already know. So pressure is thrust upon area. This is the what we say, the formula of pressure, okay. So this is what we say, okay. Now what is gas and liquid pressure? At the very first we are going to study about liquid pressure. If we take any kind of vessel, okay, and we put liquid in it, we already know that the molecules of liquid doesn't stop at any length of time, no. So they will continually move, okay, so they will continuously move. So the molecules of the liquid will continuously move here and there in all the directions, clear. So when they are moving, they will exert some pressure on the sides of the walls of the containing vessel, okay. So the molecules of liquid will exert a force, okay. They will exert a force at the side of the vessel. When they will exert the force at per unit area, when they are exerting the force at per unit area of the containing vessel, of the side of the containing vessel, then it is called liquid pressure. So they are applying pressure, and that pressure which is exerted by the molecules of liquid, that is known as liquid pressure. See, pressure exerted by molecules of liquid on sides of containing vessel is called liquid pressure. So the molecules of liquid are exerting pressure, clear, on the sides of the containing vessel. Now what is gas pressure? This is also same. When we take an enclosed vessel and it has gas in it, it has air in it, okay. So when there is a enclosed vessel and it has air in it, the molecules of air will also randomly move here and there. They also does not stop at any length of time, no. So they will randomly move here and there, and that molecules are exerting pressure also, are exerting force at the side of the containing vessel, of that enclosed vessel. So they are exerting force, and that force which is exerted by the molecules of gases per unit area is known as what? Gas pressure. It is simple, guys, clear. Now we are going to study some effects. When we reduce the volume, when we reduce the volume of the gas, what are the effects which are being produced? We are going to study. See, we have to take a vessel, okay, and airtight piston you have to take, and the vessel must be filled with air. See, like this is a vessel and it has a meter also. It should have a meter. So this meter will help in seeing what is the pressure exerted by this gas which has been enclosed with the help of piston, clear. So we take a vessel, we have a meter for checking what is the pressure, and we have taken a airtight piston. Now the piston, when we push the piston, and now we are taking this volume, the volume which is enclosed by this vessel is 20 centimeter cube. So this volume is 20 centimeter cube, okay, this air which is filled in this vessel, and this is airtight piston, so air cannot go. Now see, and there is meter also. When we check the meter, what is the pressure? It will be written 760 centimeter of Hg. You can say mercury. Okay. So just an example I am giving. Don't take it serious that it must be like this way. Okay. So when we are exerting pressure, and this is the piston which has been occurred so that no air can escape, and this is 20 centimeter cubic the volume, 20 centimeter cube. Now the pressure is 760 centimeter of Hg or mercury. Now see, when we reduce the volume, now we are reducing the volume. We have pushed the piston with force F. Okay, this is the force, and we are reducing the volume to 10 centimeter cube. We have reduced the volume to half. Now what we are seeing? 1520 centimeter of Hg or mercury. The pressure is just double. How it has been double? So first we are concluding that when we decrease the volume, of air, then the pressure becomes double. Now how it becomes double? See, this was the initial pressure and this is the final pressure. Okay. Now see, in the initial pressure, what was there? 20 centimeter cubic was the volume. And now in the final pressure, what was the volume? 10 centimeter cubic. Now we have decreased the volume to half. When we are decreasing the volume to half, the molecules which are there in per unit volume are becoming double. They are becoming double because we are compressing it. So they will become double. So the molecules in per unit volume, they will become double. Okay, and hence they are becoming double. So they will randomly move and they will exert double force. And as the double force is exerting per unit area, so double the amount of pressure will be there. Okay, so it is obvious that the amount of pressure will be there if the double the molecules are exerting the force. Clear? In per unit area. And conversely, when we take up the piston up and we are making it to 20 centimeter cube. Now what we have done? My initial volume is 10 centimeter cube and now the final volume is 20 centimeter cube. So I have doubled the volume. Okay. And the initial pressure is 1520 centimeter of mercury, and now the final pressure is 760 centimeter of mercury. Okay, we are converting it. Now see what is happening. When we are increasing the volume, we are doubling the volume. Okay, then what is happening? See, the molecules which are there in this, per unit volume becomes half when we are increasing the volume. Okay, so the molecules which are there in this vessel are becoming half. Okay, they are becoming half when we are increasing the volume. Clear? So when the molecules become half, so they are exerting the force on the side at per unit area, and that force is becoming half because the molecules have become half. Okay, and when the force become half, ultimately pressure will also become half. Clear this thing? So this is the gas and liquid pressure. So bye bye guys, we'll meet in the next time very soon. Thank you.